Alright, to solve this quadratic equation using the quadratic formula, the first step is simply just to identify the coefficients here. So the definition of the quadratic formula is listed here based off A being the quadratic coefficient, B being the linear coefficient, and C being the constant coefficient. You can find the solutions using this formula right here. Alright, so first to identify those coefficients, in this case A is negative 20, B is negative 6, and C is 8. Okay, so just typing these in, writing these in the quadratic formula, I would get that x equals negative b, which is 6, plus or minus the square root of b squared, which is 36, minus 4 times a, which is minus 20, times c, which is 8. And that's all over 2 times a, or 2 times negative 20. Now the real work is simply just cleaning things up here and getting our solutions. So let's deal with the stuff under the square root first. So we have 6 plus or minus. When I evaluate this expression right here, by the way, this thing's called the discriminant, for any who cares, the number that appears underneath here. This is 676. It's called the discriminant, by the way, just because it determines the types of solutions that we'll end up getting. Okay, now we need to simplify this radical if we can, and 676 is actually a perfect square. It ends up being 26 times 26. So to simplify this more, we get 6 plus or minus 26 over negative 40. Now because this radical simplified down to a perfect square, this means that we're going to get rational solutions. And basically we just need to compute what these solutions are. So there's two solutions. It's when 6 plus 26 is being divided by negative 40, and when 6 is subtracted by 26 and then divided by negative 40. So we'll compute each of those separately. So the first solution is 6 plus 26 over negative 40, which becomes 32 over negative 40, and by reducing that by canceling a common factor of 8, we get negative 4/5. And then our second solution is x equals 6 minus 26 over negative 40, which is negative 20 over negative 40, which when we cancel the negatives and the common factor of 20, we get 1/2. And again, we expect to get two solutions to quadratic equations. These are our two separate solutions to this problem.